Hello, good afternoon, everyone. Welcome to UTA Planetarium's live star stream and Ask Astronomer. I'm here. This is Levent Kurdemir, and I'm here in the studio with Jim Bader, right here. And today we are going to continue with some of the news from space. And Jim, did you see any meteor shower?
The Perseids, yeah, I got to go out and look a little bit. I didn't see too much this year. I know that the conditions are supposed to be good. I know there wasn't a bright moon in our way, but I really didn't see that many. I don't know. I know it was supposed to be around 60 an hour, and it felt a little less than that. I was probably out there for 30 minutes, and I saw two maybe, so it felt bad, but
I did not see anything actually. Well, the sky is a little bright in the Dallas-Fort Worth area. We talked about how light pollution affects our night sky, and also as I mentioned last week, the prediction is only depending on the moon's visibility in the sky, because when there's moonlight, there's a lot of light. We cannot see much in the sky. So this year was predicted as one of the best, but that is coming from the moon's non-existence in the sky. So still didn't give a lot of nice fireworks. So hi Lamia, how are you? I hope you are doing well.
We have a response to a question, Lamia, and I'm sad to say that I won't be able to do the exciting experiment that I was hoping to do. It didn't translate well to camera, but we're still going to get into that in a little bit.
All right, let's start with
it. We're jumping into that. Okay, let's do it. So
what was the question anyway?
The question it was a little spread out of a question, but I do have it here. I think what the question we got was, are there rules that determine planets' orbital directions, tilting angles, and rotating direction? So I just want to ask you, Levent, is there a rule or is it simply random?
Well, unfortunately, we do not make the rules for nature. Nature nature have the rules, and we are trying to figure them out. There is like one common way for rotation, and that is if we are, let's say, looking from the north side of our pole. That means like this is the bird's eye view to our solar system, but we can look from this direction, and also we can look from the other direction. So this is the direction we see the northern hemisphere of Earth. So if you look at that from this direction, all the planets will look like orbiting counterclockwise around the sun. And most of the planets are going to be also spinning in the same direction if you look from this point of view. And that's because it's actually coming from the solar or the sun's birth. We need to go back into the formation of the sun because everything in the solar system was formed from the same material called solar nebula. And this solar nebula, it was like a cloud dust, and that dust the shrunk at the center and formed the sun. And also the outer regions of the dust also shrunk by gravity and formed the planets, and formed, of course, many other things in the solar system like asteroids and comets. And some of the post interactions like collisions changed the behavior of some of the planets and some of the comets. So from that point of view, every orbit seems to be orbiting this way because the solar nebula was probably spinning that way at the beginning. And there is no reason to change the spin direction. So after the formation of the solar system, everything is still moving that way.
So this is where things get a little confusing after this event. And I say this because it's really not confusing, but at first glance, it can be a little misleading. So there are, all the planets in the solar system rotate the same direction, right? Except for two, in a way, Venus and Uranus. But that reason that they rotate backwards is a little complicated. Do you want to elaborate on why they rotate backwards?
Yes. We cannot know for sure because we were not observing the solar system back in time. But probably we can say what happened was, and most likely, a collision. So the planet is formed just like other planets. So every planets are nearly at the same age. So that shows that they formed from the same material, same time. And but some of them afterwards, the planets are also orbiting around their axes. Again, the post formation, after the solar system is formed, the planets start orbiting or started appearing around the sun, but the orbits were not stable like these, and there may be some other planets around whose orbits are not really free. So those planets or different objects actually likely ran into different planets, and when another object ran into a planet or collision, of course the dynamics of the planets will change. So this is probably what happened to Venus. It kept the nice and right direction orbit around the sun, but changed its orbital, the axial rotation around its planet.
It's definitely weird to me how we define this, and I think what you're saying is, I mean, there's no way you can say what you're saying is wrong because nobody was here to see it happen. But that we say Venus spins backwards, but instead of saying Venus spins backwards, we say that it's actually just tilted completely the other way. And then the same with Uranus, we say Uranus spins backwards, but it's also, instead of saying that Uranus is tilted 83 degrees, we say that Uranus is tilted 97 degrees. And instead of saying that Venus is tilted 3 degrees, we typically say it's tilted 177 degrees. And I don't know. It's like a solution to saying they don't spin backwards because they're tilted beyond 90 degrees.
I'm trying to find a spherical object around me, and if you have anything on your desk, please hand it over, because it's very easy to explain this with a spherical object rather than talking. Oh, great. Here you go. Now we are doing a real teaching. So the planet spins in one direction. Let's say it is spinning this way. So when it collides with an object, let's say towards the pole, an object hits, and slightly gave a speed to that planet, and that planet will just go upside down like this, but it will keep spinning in the same direction, and it will look like spinning the other way after the collision. So this is probably what happened. So the Venus was maybe like this initially, spinning, and an object hit, and it just went upside down with the impact. For Uranus, it was like this, spinning, and then it went sideways, 90 degrees sideways after the impact. So it is spinning, but it seems like it is spinning and rolling on its orbit like this.
Okay, so we answered destroying our studio. We answered that question, but another question comes up, Levent, in this. While the question did ask, is it random? Which I think your question is, or your answer is, yeah, essentially. But everything, like chaos, disappears and stuff starts spinning the same direction. But is it possible that there are planets that either orbit their planet or orbit their star the opposite direction the star is turning, which is not what we do. We orbit the same way the star is turning, or that all the planets just move backwards from the star. And the one answer we have with evidence is that some planets do orbit opposite direction that their star turns. But it's from what, I mean, it's hard to see other planets, right? But I'm assuming it's rare because of simple angular, physics. What happens when you start rotating?
Yeah, well, it's not the case for the solar system, but for other stars, we need to look into that. Discovered 6,000, more than I think 6,000 now, planets orbiting around other stars. And again, the theory of formation is there is a nebula, and that nebula spins, and then it forms the star at the center and the planets around it, and sometimes it forms 2 stars, 3 stars. So I think that all depends on the initial conditions of the nebula, and also what happens after the formation. Again, the earlier solar system was actually like a shooting gallery. There were a lot of collisions, and because of that, the Earth's surface was actually molten. For millions of years, the Earth's surface remained as like a molten lava because there's too much impact from the space.
All right, so bottom line, Levent, is it just always the same direction, or is it random and it works itself out?
I wouldn't say it's random, but it is mostly the same direction.
Okay, well, I think that answers it. As clear as I think you could be.
There's also, the little bit physics behind it too. Always the things in the universe wants to be in the least energy state. Pretty much like, we also would like to be in the least energy state, right? We are just finding a comfortable position on a comfy chair, and that is the state we would like to stay. We would prefer this after or for like running around with rush. So the matter or the everything in the universe is the same way, and when everything spins in the same direction, that is the least energy state for the angular momentum. For that reason, we think that everything, at least initially, spinning at the same direction.
Very interesting. Definitely. Thank you for that. And hopefully that answers the questions. And this also goes for everybody else in the future. If you have questions, you think of something, you're on your lunch break on a Friday, and you're like, I wish I understood how that worked. Drop it to us. It gives us content. It makes these things way more interesting. And I think as both educators, Levin and I enjoy this stuff. So please, more of those questions for sure. All right. New stuff, Levent. Do you want to go to Saturn first, or do you want to go to Venus first?
Well, Venus is closer. Let's go to Venus, then we can go to Saturn.
Low energy state.
Low energy state. Yeah, that is the physics or nature law.
All right, we're setting things up for this. So, to
Least
get into this
possible
news,
action principle.
yeah, to get into this news, there was some scientific papers, Levent, that said that the core of Saturn and just by association, probably other gas giants, and by that they're really referring to Jupiter because I think Uranus and Neptune are a little wild, likely have fuzzy cores. What's your take on a fuzzy core? I have a lot of problems with that term, but yeah.
Well, I regret to the fifth graders, we always say, gas giants are just a sphere of gas. If we go with a rocket spaceship, we cannot land on them because there is nothing to land. This is actually not exactly true. The gas giants they have like very thick and dense atmosphere. You can imagine them like a regular planet, but they are different than the other planet, the Earth-like planet, Earth, Mars, Venus. When we cut a slice in them, we can have that nice feature. We can cut slice, and if we can just a little bit tilt it, Jim, we will see that we think there are some layers, just like our Earth. Our Earth has atmosphere, not this thick, but it has atmosphere, and also there is like a rocky crust. And under rocky crust, there are different layers of, it goes like a magma, and then, we have some layers until we reach out to the core, which we also think at Earth at a liquid state, or the matter is in the plasma state. So when we look at these planets, we think that there's a thick and dense atmosphere on the outside. This is what we see from when we just directly look at the gas giant planets. But also we are now estimating that there is like a planet-like core, but this planet is not like a solid rocky object. And the study, especially you mentioned, is referring a core that the mixture of ice and dust and some liquids.
I have to interrupt you for 2 seconds. I just want to apologize for the wild driving since Kevin is giving me a hard time. Anyway, go ahead. Sorry. The core.
So the core, yes. Yeah, the core is, we think that, or that study suggests that some rocky elements and some ice and some metallic fluid is in there. And also the core extends to the 60%, so the core should be like,
that's way bigger
here.
Yeah,
the 60% of the diameter. So the estimated the big dense atmosphere may be actually thinner on gas giants. That means maybe if we go with a spaceship, we may be able to land.
Well, the diffuse core makes it a little, but you're right. I mean, it's not what we thought before. It's not like, if you had a little core like what's depicted in this image, in order to get there, you would be smushed.
At least what we know that if we just aim a spaceship, unmanned spaceship to gas giant planets, it will not go from one side and come from the other side without any problem. It will run into some matter, mass, particles, something.
It certainly seems wild. So the way that they discovered this is kind of crazy. They used old data, which we're going to get into another recent paper that used old data. They looked at ripples in Saturn's rings, and they said, hey, these ripples aren't always the same. And then this is all from Cassini spacecraft, which saw this old data. They took that data and they ran models on it to try to model what could possibly cause this. And the only explanation that they could come up with, which doesn't mean that's the only answer, but the explanation they could come up with said that its core has to be much bigger, much less dense, and weird. Fuzzy. I don't like that word, fuzzy.
Well, as you see, there's a lot more to explore in the solar system, and the inside or interior of gas giant planets still remain a mystery for scientists. I mean, it's mystery because we have not discovered yet. We have not sent qualified spacecraft for that specific missions, and Saturn was only looked into with Cassini spacecraft. So hopefully in the future there will be more and more unmanned robots to explore these planets.
That are clever ways to look inside of it. I mean,
yes,
it's pretty opaque, so you can't just look.
You mentioned about Venus. What is going on with Venus?
We got to go to Venus. I forgot about that. That's important. So Venus has volcanoes, Levent. We did know that, but apparently they're active a lot more recent than we expected. What's your take on discovering a more active core on Venus than we thought?
Well, that was also some scientific question that we know Earth and Venus formed in the similar time, and Earth have active volcanoes as we know it, and that is very important to support life. But the Venus, it seemed like there were a lot of volcanic activity in the past, but we did not see any evidence recently. I mean, I'm saying recent, don't take me like, talking about 10, 30, 50 years. For the past million years or few million years, we were looking for the evidence because it seemed like this planet have, it's a troubled planet. Its atmosphere is all poisonous, so we cannot live. It's about 900 degrees on the surface. It is certainly not a great time to spend summer or even winter. And this planet was not showing any volcanic activities, and this was puzzling scientists, like why? And one of the theory is because Venus doesn't have any moon around it, and Earth have one moon and Mars have two tiny moons. So maybe moon is the factor to keep an volcanic activity active for a long time, but this is not a very strong evidence because Mars moons are tiny moons, and Earth's moon is a good size moon, but still doesn't explain a lot of things.
Definitely.
So finding the volcanic activity, I think scientists need to look down further and maybe just to think about the theories and maybe collect more data on that.
Good news. It's a good thing you said that, Levent. Very good thing. In case the viewers didn't know, we did mention this, but there are 3 new missions slated to go to Venus. So orbiters, stuff that's going to land and collect data from the actual ground, which is crazy. And this is fantastic. So hopefully we'll have those answers. I think it's kind of wild the way they did this. They looked at Magellan spacecraft information, and Magellan spacecraft was there in the early 90s. So they were taking data from the 90s to answer these questions about volcanoes on Venus. We have so many techniques to deal with massive amounts of data now that people are going back through earlier spacecraft stuff and doing that. Patricia asks, when are they going to Venus? Soon. I wish that I had a date to give you, but they just got cleared. All the projects got cleared by NASA and ESA this year. So it's kind of wild that they said okay to 2 Venus missions this year at NASA, and then ESA also dropped an okay for one from theirs. That seems like, what did Venus do?
Well, it orbits in the other direction, and also one more thing about
so
Venus.
Applicable.
Its rotation rate is very slow. It takes about like one spin, which we call one Venus day, takes 225 days on Earth. So it's a very slow rotating planet, and day is actually longer than its year.
Yeah, that's wild.
So that's very.
But the lack of tilt means that there's no real seasons. There's
no
just daytime and nighttime, and they're both awful.
But the size-wise, it is pretty close to Earth.
Yeah, and it has atmosphere.
So this is one of the challenging questions to answer. Venus and Earth are so close. They are both in the, we can almost say, habitable region, and they formed at the same time from the same matter. Why Venus have a lot of troubles like these, and the Earth is a nice habitable place.
Really interesting, for sure. I just want to bring up a problem I just discovered. We had a poll going while you guys were here, and we've had several responses. So I want to publish this so that we can talk about this. 100% of you guys did not see the meteor shower. I'm so disappointed and so sad.
You are not looking up.
Yeah. I mean, it's my job, so I feel like, I kind of have to do this, but it's really...
No, I cannot blame everybody because sky is too bright. This is one of the thing about light pollution. The things never catch our attention because there's so much light and there is not much interesting going on. And when I tried to spot a few meteors during the meteor shower, and I couldn't. At least I thought I saw one because I saw some, it was a little cloudy and I saw some bright light moved quickly in the sky. And I looked at the spots that I thought I saw the meteor, and it was cloudy. One instance I thought, was it very bright meteor that I seen, like even the light penetrated through the clouds and I was able to see it? And I was just looking at the same direction, I saw the same thing again. And apparently that was one of these old style, the big giant spots, they shine toward the sky.
Bat signal.
And it moves, and it was one of those because it was periodic. All right, what Kenneth says, Venus is our problematic sister. That is not a politically correct word, so I will not use that.
Yeah, some people have problematic sisters. I have one. She's out of control. All right. Here's a picture, since you all missed it, behind Levant. This is a picture from 2021, this year, of the Perseids from a beautiful dark sky, 30-second exposure. Looks fantastic. You can see the Milky Way in there. So just a quick glance of what we missed. I didn't see much myself, but yeah, we have one in there.
And I would guess this is Jupiter? Maybe.
It was, I don't know. It looks like it's going away, so I'm going to say that above your head is probably where Perseus is. So if Perseus is over there, Thuban, Polaris, I don't know. I think it's in the north. Yeah, no idea. We should check. I should do some other guesses. Patricia says, I guess I need to go to the country. Needed to. Yeah, we all need to do that sometime.
Yeah, sky is a lot better from country. If you go far away from city, anywhere is good too. The difficult thing is finding a safe place. Especially if you are going somebody's house, that's fine, but don't do anything like stopping on the highway because it's very dangerous. A lot of people actually having major accidents by just stopping on highways to look at the sky. And
just go to a state park.
Sleepy driver veers off from the road. There are a lot of them. Be careful.
Yeah, be safe. But yeah, definitely, as Lamia states, living in cities has drawbacks for sure. Agreed. Anyway, that does it. There's a bunch of news that we need to talk about regarding Perseverance. But I decided to let this episode be a little more astronomy, and next episode will be a little bit more spacecraft related. So we'll cover that. And update, we will be having a guest on the show September 1st. So put that in your calendars. Will be an exciting show. And we're excited to have, we'll announce the name soon. I've got to get an ironclad commitment, and then we will get to that. But September 1st will be a good show. Anyway, anything else, Levent?
I think I don't. If you have any questions during the week, please let us know so we can prepare some material rather than just talking.
You can send us a message on Facebook or email.
Or you can encourage your friends, the people who you know, to get involved with the live stream and ask questions if they have any, because I know that a lot of people have a lot of questions, and sometimes it is difficult to find the people to ask them. So use our social media and let us know.
All right. Well, that does it for the show. Thank you, guys.
All right. Hope to see you next week.
Bye-bye.